Okay, so today is day 2 of the law of signs, and we're going to be dealing with the ambiguous case today. Okay? So, the ambiguous case is when you are solving a law of signs problems, but there could be more than one answer. Okay, so we're going to start off by looking at this example here. Okay, we're given a triangle demonstrating using the law of signs that is a valid triangle. Okay, the numbers are rounded to the nearest tenth, so they may be a little bit off. But in this problem here, okay, if you've noticed the whole numbers, these here, that's what we were given. Okay, and we found angle B, angle C, and side C. Now, is this a valid triangle? Well, how would we be able to tell? Well, we could look at the angle values and the side lengths, but the best way is that the law of signs says that sine A divided by A has to be equal to sine B divided by B, which has to be equal to sine C divided by C. So basically, this sine of 40 degrees over 5 has to be equal to the sine of 64.1 degrees over 7, which has to be equal to sine of 75.9 degrees over 7.5. So we're going to plug these into the calculator and see what they give us. Okay, and when you plug them into the calculator, so when we plug that in, we get 0.128 for all of them. Now there is a little bit of a rounding error, okay, but basically all three of them are equal to that. So since the law of signs says that those three things are equal, then this is absolutely a valid triangle. Okay? Now let's look at this example. Example 2. Is this a valid triangle? Okay, now notice we start off with these same values, but notice this right here, the other three that we found are now different. Is this a valid triangle? And the same thing, if we use the law of signs to verify it, we find that it absolutely is. And we get the same value. We get that 0.128 that we did on the last one. Well, why does this work? How is that possible? How do we have two triangles given the same three pieces of information and create two different, completely different triangles? Okay, well, let's look at what we got. So when we look at them side by side, okay, in both cases, side A and side B and angle A are exactly the same. So two sides in an angle, but they produce two different triangles. Why? And it actually comes back to what we were just studying with the inverse trig functions. If we look at it and we say, okay, when we solve it, we actually have to solve for angle B doing this, using the inverse sine function, the arc sine. Okay? And 0.89, that's in the first quadrant. Okay? But there is a second value where sine is 0.899999. And it happens actually in the second quadrant. And when we look at that, we find that both of these sine values have the exact same value. So what's happened here is we could have one triangle being this one and one triangle being this one. Now, the calculator will never give you back this value because the arc sine will never give you back anything from the second quadrant. But also, if you notice, if you add up those two angles together, 115.9 and you add 64.1, you get 180 degrees. Okay? And this is how the ambiguous case works, is that when you have B being a possibility of two different answers because of the arcsine value. Okay? So that one is an acute triangle and one is going to be an obtuse triangle. And that basically leads us into the ambiguous case. So the side-side angle case is our ambiguous case. So there are three possibilities when we deal with this. The first possibility is we have no solutions. There's not even a triangle. We can't create a triangle. The second option is that we have just one. And then the third is we could have possibly two triangles, one being the acute and one being the obtuse. So to kind of put this all together, this chart does it very well. Okay? And this is right out of your book. These are the different cases. This is the ambiguous case. The ambiguous case only deals with side-side angle. Okay? So if you're given a triangle where you're given two sides and this angle A. Now, this angle that we're given, if we're given two sides, has to match up with one of the sides given. So if I'm given side A and B, this angle has to be either matching A or B. Okay? And if that's true, okay, then we have these possibilities. So these three right here, four, are if the angle they're given is acute. Okay? So if I'm given an acute angle and two sides, then I can have no solutions, one or two. Okay? Now, on the other hand, if I'm given an obtuse angle, I only have two possibilities. Either there's no solutions or one solution. Okay? And this is how it works. Basically, you can see in this chart, if these are my two sides given, okay, side B and side A. If A is not as long as the height, if A is smaller, the side they're given is smaller than the height of this triangle, and this is the equation for the height right here, then basically A can't even come down here and touch my third side, and it can't make a triangle. Okay? So this side has to be equal to the height, at least. And if they are equal, then you have one triangle, and you know it's a right triangle. Okay? Now, if A is bigger than the height, but then we have to qualify it with B. If A is bigger than the other value they gave us, then there's only one. But if A is bigger than the height, but smaller than the other side, that's when we get this two possible triangle existing. Okay? So I would definitely suggest in your notes that you print this out and paste it into your notebook. If you're writing your notes, I wouldn't try to write all this by hand. This would be one of those times where I'd say, hey, print this out and just stick it into your notebook. Okay? So let me show you how this ambiguous case works. Okay? So I've been given this triangle. Okay? I've created this triangle, again, just like the ambiguous case, where they've given me this, this, and that. So notice these are not going to change. This angle here and those two sides, they are not going to change. Okay? But if I take this side, side A, okay? What if I swung it in like this? So instead of once it leaving C coming out this way, it swings in this way. Notice the length is exactly the same. Okay, I didn't change this length, I didn't change this length, and I didn't change that angle. The only thing I did was I changed angle C and moved side A in like that. That means it'll look something like this. And that's where my second triangle comes in. Okay? And you can see it right here, and this one really, really well. You have one triangle that goes like this, the outside one, and then you have this other one here that creates a second triangle inside, like this. And you used to do problems like that in geometry. Okay? And that's how the ambiguous case works, is that you can have either of these two triangles. And notice, again, side A, side B, and angle A have stayed the same. But I have two possibilities that I can get. Okay? That's the ambiguous case. So, this ambiguous case, these are basically the thought process you need to go. Okay? Whenever you're solving triangles, number one, you got to figure out, is it a law of sines or a law of cosines problem? Okay? If it's a law of cosines problem, then you're going to solve based on one solution. Law of cosines, there's only a possibility of one solution. Okay? If it's law of sines, we go on to step 2. If it's a law of sines, is it the SSA case? Do you have two sides and an opposite angle? No? Then you got one solution. That's it. No worries. If you do have this case, then you've got to go on to and check the ambiguous. Okay? Is the side opposite of the angle the shortest side? If no, it's not ambiguous. You got one solution. If it is, then you go on and you've got to figure out how many solutions. Is it obtuse? Then it's one solution or no solutions. And then if it's not obtuse, then you have to do the whole case where you got to check, does it have 0, does it have 1, does it have 2? Okay? Now, it's actually a lot easier than you think. Okay? And that's what we're going to practice. So, for this one, do I have the ambiguous case? And how many solutions are there? So I look. I'm given side A and side B. Am I given an angle that matches one of those? Yep, I'm given angle A. So this could be the ambiguous case. So the first thing I need to do is I need to look. Is A bigger than B? Yeah. Now we could check the height using the height equation. Okay, and if you look, the height equation is the height is equal to B times the sine of A. And if you plug that in your calculator, you could check to see if A is bigger than the height, which it is. Okay, but since we see that A is bigger than B, we already know there's only one solution. Okay, that's how easy it is. So we got another one. Okay, so I've got the ambiguous case. How do I know I have the ambiguous case? I've got sides A and B, and this angle matches one of them. So it is my side-side angle case. Then I look. Is this bigger than this one? No. So that means that I don't have one solution. I could have either no solutions, okay, or I could have two solutions. So now I got to check my height. So again, I go back to my equation, my height, and see if there are, in fact, solutions. And yes, it's bigger than the height, so I have 2. Okay? And if you check the height on this one, the height is actually 4.6. So is this bigger than the height? Yes, barely, but it is bigger than the height, which means this is in between 6 and 4.6, and that's why we have 2 cases. Okay? All right, the next one. Now, one thing you can do, the names of the sides and angles you're able to change them up as long as you keep them consistent. So for like this one, if I wanted to, I could actually rename this side A, and then this becomes angle A to make it easier on me. Okay? So the first thing I'm going to do here is I'm going to check my height. Okay? I've got an acute angle, so I'm going to check my height. So I plug in 5 times the sine of 80, and it gives me my height, which is 4.9. So this is bigger than the height, and it's bigger than my other side, which means there's only one solution. Okay, that's all we're doing. We're doing this just over and over again. Okay, so is this the ambiguous case? Got two sides and an angle. The angle matches one of my sides, so yes. First thing I'm going to do is I'm going to check my height. So it's going to be 8 times the sine of 40. And in this case, my height is going to be 5.14. My height is 5.14, but my other side is only 4, which means that I have 0 solutions. Okay. Now, this one, is this the ambiguous case? How many solutions does it have? Well, this is side, side, side. One of the things that you learned in geometry was that given 3 sides, you can only make one triangle. Okay, so if it's not the ambiguous case, then you don't even have to check. You automatically know it has one solution. As long as the other thing that holds up, that you have your 2 shorter sides are longer than your 3rd side. Okay, but it's not the ambiguous case, so we don't have to check it. All right, this one here. Is this the ambiguous case? I have 2 sides and an angle, but does my angle match one of the sides given? Nope. So that's not the ambiguous case, so there's only one solution. We don't have to check the height or anything. This one here. Is it the ambiguous case? Yep. We got 2 sides and my angle matches one of the sides. So again, since A is smaller than B, we got to check the height. So we do 6 times the sine of 25. And we get the height of 2.5. So A is bigger than the height. So this has how many solutions? Since A is between the 2, there are going to be 2 solutions. See? Easy. And the last one, is this the ambiguous case? Nope. Because I got 2 sides and an angle, but again, my angle doesn't match one of the sides given, so automatically it has one solution. Okay? So that's something you're going to have to realize. Before you start going and solving triangles, you need to make sure that it even has a solution. Because you're going to feel real silly if you start solving it and it doesn't have any solutions. Or you only solve it for one when there's actually more than one. Okay? So we got to practice. So this is a single solution problem. Okay? I know there's only one solution because the A that they gave me is bigger than my B. Okay? But it is definitely the side-side angle case. And we solve it just like the other ones we did. Since we know it's only got one solution, we just basically set up our law of sines. I'm using the reciprocal form, finding angle B first. And I find angle B is 21.41 degrees. Okay. Then, using that, I find my third angle by finding angle C, because all 3 have to add up to 180. And then using it to find my last side, side C, which is 29.4 inches. Okay. So the ambiguous case doesn't mean we solve it any differently. It just means that we have to look at a couple of things first. Okay, we got to look to see if we have more than one solution. Other than that, we work it exactly the same.